Okay, in this lesson, we're going to look at solving quadratic equations by factoring. You should have your notebook already set up in your Cornell notes, and your essential question was written in your module. So the first question I want us to answer is, when can we use factoring to solve? So think about that for a second. Can all quadratics be factored? And I hope you realize no, because we talked about that there are prime trinomials. But basically, we can use factoring to solve a quadratic if the quadratic equation can be factored. If it can factor it, then we can use factoring. Factoring may not be your favorite method, but as long as it can be factored, we can use factoring. The next thing we need to talk about is the zero product property. And I've listed it for you in your notes. The zero product property tells us this: if the product of two real numbers is zero, then at least one of the numbers has to be zero. And so I gave you the algebraic definition on your notes. So if we are saying A times B is zero, then we know that that means either A has to be zero or B has to be zero for that equation to equal zero. A would be a factor and B would be a factor. Remember, at any point, if you need to stop the video to write down a few notes or a few clarifications, please don't hesitate to do that. It's not always good to leave the video running while you're taking notes. So here's an example of the zero product property. We have the equation y plus 2 times y minus 6 equals 0. This equation is already factored. It's in factored form. It is equal to 0. So we don't have to do anything special to this. And so the way we would then use this property, it says that because we're multiplying and equal to 0, then either y plus 2 has to equal 0 or y minus 6 equals 0. And so now what we're going to do is take each factor that we've set equal to 0, and we're going to solve the equation to find our roots or our solution. Our solutions would be -2 and +6. If you look at our first equation, y plus 2, we would always obviously say -2 from both sides, and that's how we get -2. In y minus 6, we would add 6 to both sides, and that's how we get 6. Okay, so here are some steps that I've listed also for you in your notes to using factoring. And I know I've included the word binomial in our steps, but it also applies to trinomials. Number one, we need to make sure our equation is equal to 0. So we're still thinking standard form equal to 0. Once we have it equal to 0, we're then going to factor it. After we have our factors, we're going to put each factor equal to 0, and then we're going to solve each of those equations to find our solutions. Now we have to remember our factoring rules. Here we have a binomial. Remember, there's only two ways to factor a binomial: pulling out the GCF or using our difference of two squares rule. Notice this is not in descending order, but it is in ascending order. So we don't necessarily need to rearrange this equation as some of you might feel like we need to. So here my greatest common factor is 2q, which leaves me with 9 minus q. I then take each factor, 2q and 9 minus q, and set each one equal to 0 because we know one of these has to equal 0. And so here I would get a solution of, whoops, and I put z instead of q. Q equals 0. Over here we would subtract 9 and then divide by this negative or -1, and so that's how we get +9. Okay, and the next example, 3n squared equals 9n. Hopefully you're immediately realizing that we need to put it equal to 0. Take a minute and see if you can factor that yourself. Our greatest common factor was 3n, which would leave us with n minus 3. We now put each factor equal to 0, and we get a solution or roots or zeros of n equals 0 and 3. Now the next two examples are trinomials, and I'm going to encourage you for a minute to maybe just look at those yourself. See if you remember how to factor trinomials, and see if you can get some solutions on your own by pausing the video and then start it back up and see if your work matches my work. And obviously if it doesn't, we need to fix it. So the first thing here is we do need to get it equal to 0 by subtracting 7. And now we're going to factor this. Remember, to factor a trinomial, we started out by making an x. If you need to write it by using the grouping, you can. Remember, you can also use the box method. We learned lots of different ways, but this factors to y minus 5 and y plus 3. Put each factor equal to 0 and solve each of those equations. And so we should get that our solutions are 5 and negative 3. Okay, again, we need to make sure that we get this equation equal to 0. We're going to start by factoring out that negative 1. Make your x. You're going to have to use grouping or a box to get this. So you can see here how I've regrouped. I'm ignoring this negative 1 for right now. And I'm just showing you our methods for factoring this. We get that our factors are negative 1, 3n plus 5, and 4n minus 3. We don't have to worry about putting negative 1 equal to 0. It doesn't have a variable with it, so it's not going to be a root or a solution. And we get the solutions of negative 5/3 and 3/4. Okay, the last one. This is really, really hard. Can you do it by yourself? Could you try to do it? We have to get it equal to 0. So that should be our first step. And I'll give you a little hint here. Is this a perfect square trinomial? Could I use my perfect square trinomial rule to factor this? Well, obviously, yes, we can. 4/9 is a perfect square. X squared is a perfect square. And this right here gives me twice the product. So this particular equation, x minus 2/3 and x minus 2/3 is the same factor. So I'm not going to have two factors that I need to put equal to 0. They're going to come out to the same solution. There is only one solution here. And so you'll notice my question on your notes is, what does this mean? What does one solution tell us about the graph of the equation? So if you please write down your thoughts, and I will expect you to be ready to discuss this in class.